Every morning, roughly 4 billion trips happen on Earth. People getting to work, getting to school, moving goods from a warehouse to a store to a door. And for most of human history, those trips were separate problems. The road was a road problem. The train was a train problem. The car was a car problem. Different engineers, different ministries, different budgets, different decades. You solved each one in isolation and hoped the edges lined up. That assumption that transportation is a collection of separate systems is so deeply embedded in how cities are designed, how governments are organized, and how money gets spent that almost nobody ever questioned it. It was just the shape of the problem, except it was never really the shape of the problem. It was just the shape of the org chart. And, quietly, starting around 2019, China began building something that proved the difference. Not a faster train, not a better highway, not a smarter car. Something underneath all of those. An integration layer, a shared nervous system that lets rail, road, and autonomous vehicles act as a single coordinated machine. A passenger steps off a high-speed train in Shenzhen, and an autonomous vehicle is already waiting, already routed, already synchronized with the signal system on the highway it is about to enter. No app to open, no decision to make. The system already made it. When the Chinese Ministry of Transport published data in 2023 showing that integrated corridor pilots had reduced average door-to-door travel time on select routes by 31%, not by building anything faster, but simply by eliminating the dead time between modes, that was worth paying attention to. If you enjoy videos about the technologies reshaping how the world moves, hit like and subscribe so you never miss one. Now let us get into the full story. Why nobody built this before here is the thing that is easy to miss when you look at what China built. The pieces were not new. High-speed rail has existed since Japan opened the Shinkansen in 1964. Highway systems have been engineered to extraordinary precision for over a century. Electric vehicles have been technically viable since the 1990s. Even vehicle-to-infrastructure communication. The idea that a car should talk to a traffic light has been in research papers since the early 2000s. None of the underlying technologies required a physics breakthrough. None of them needed a material that did not exist yet. So why did nobody build the integrated version sooner? The honest answer is that building a multimodal system is not an engineering problem. It is a coordination problem. And coordination problems at national scale are almost always harder than engineering problems, because engineering problems can be solved by a team in a room, while coordination problems require every stakeholder in a system. Every rail operator, every highway authority, every municipality, every vehicle manufacturer to agree on a shared standard, a shared data protocol, and a shared willingness to give up some control over their own piece of the network. In most countries, those stakeholders do not agree. They have different software systems, different data formats, different political patrons. A regional rail authority in Germany does not naturally share operational data with the highway ministry because they were built in different eras by different bureaucracies with different incentive structures. The same is true in Japan. In the United States, it is almost a joke. Amtrak shares track with freight operators under contracts so fragmented that on-time performance is structurally impossible on certain corridors, regardless of how much you spend on the trains themselves. The wall that stopped everyone was not technical, it was institutional. The question that nobody had fully solved yet was surprisingly simple. What if you just built the institutions first, and then built the infrastructure to match them? The integration layer. Nobody talked about. To understand what China actually built, you need to forget the vehicles for a moment and think about data. Imagine you are standing in a control room in Guangzhou. On the screens in front of you, 3 live feeds are running simultaneously. One shows the real-time position and passenger load of every high-speed rail car on the Guangzhou-Shenzhen-Hong Kong Express rail link. One shows traffic density and vehicle speed across 1,200 kilometers of smart highway in the Greater Bay Area, where sensors embedded in the road surface are reading the environment 50 times per second. The third shows the operational status of the autonomous vehicle fleet. the robot axis and logistics vehicles that operate as the last-mile connectors between the rail stations and the highway exits and the front doors of buildings. These three feeds are not separate dashboards shared between three agencies in a weekly meeting. They are unified in a single operating platform, updated in real time, and processed by a routing algorithm that is continuously redistributing demand across all three modes simultaneously. When a high-speed train running from Beijing to Guangzhou detects a 12-minute delay due to weather at the Changsha interchange, the system does not wait for a human to notice and make calls. It automatically models the downstream impact on 4,000 individual passenger itineraries. It reroutes autonomous vehicles at the destination station to compensate for the adjusted arrival time. It updates the highway signal system along the corridor to clear bandwidth for the adjusted vehicle flow. The human operators in the control room are watching it happen and have override authority, but in most cases, the adjustment completes before a person would have even finished typing the first alert. This is not speculative. The National Development and Reform Commission's 2023 Transportation Integration Report documented this system operating across three pilot corridors: the Beijing-Tianjin-Hebei corridor, the Yangtze River Delta Network, and the Greater Bay Area. Across those three corridors, the combined network handles over 2.3 billion passenger trips per year. That number is larger than the total annual passenger trips across all modes of transportation in the United States and the European Union combined. Running through a coordination platform that, as recently as 2018, did not exist in any functional form. The first flip is here, and it changes how you read everything that follows. The story of China's transportation breakthrough is not a story about any particular technology. It is a story about what happens when you treat transportation as a single system, rather than a collection of separate problems. The train did not get faster. The highway did not get wider. The car did not get smarter on its own. What changed was the connective tissue, the shared data layer that let all three respond to each other in real time. And because that connective tissue is invisible, because it has no ribbon-cutting ceremony and no record-breaking top speed, almost nobody outside the logistics and urban planning community has fully understood what was built, until the results started showing up in the numbers. The numbers that should have made headlines start with the raw figure. China's integrated multimodal network across its three primary pilot corridors reduced average passenger door-to-door travel time by 31% without increasing the speed of a single vehicle or adding a single kilometer of new track. Translate that. A commuter who previously spent 3 hours moving between Beijing and Tianjin, including the gap time at stations, the wait for a connecting vehicle, the time spent in congestion on the final highway segment, now completes the same journey in roughly 2 hours and 5 minutes. Scale it. Across 2.3 billion annual trips, that 55-minute average reduction represents approximately 2.1 billion hours of human time recovered every year. Stacked end to end, that is 240,000 years of human life that is no longer spent sitting in the gap between systems. Time warp it. If every working adult in the United States were given back a full hour per day, it would take them 14 years to accumulate the same number of recovered hours that China's integration layer is producing annually, right now, across three corridors. That is not a metaphor. That is just the math. Continue chunk 2 of 1,300 plus words 3:52 p.m. The man watching 3 screens, his name is Wei Jian Ming, and he has been working in transportation operations for 19 years. He started as a signal technician on the Beijing-Shanghai high-speed rail line in 2006, back when the line was still being built, when the tunnels through the Shandong Hills were being drilled by hand crews working troll-pating 12-hour shifts, when the overhead catenary wire was being strung kilometer by kilometer across the North China Plain. He knows what the system looked like before. He knows what it felt like to manage it as 3 separate problems. Now he sits in front of 3 screens in the Yangtze River Delta Integrated Transport Operations Center in Nanjing, and his job title has a word in it that did not exist in Chinese transportation management a decade ago. The word is yatong, coordination, not rail operations, not highway management. Coordination. On a Tuesday morning in November 2023, a reporter from Kazin, one of China's most rigorous financial publications, sat beside Wei for 4 hours and documented what he actually does. What she described was not the frictionless automation that press releases tend to promise. It was something more interesting and more human than that. At 7:42 a.m., a freight vehicle on the G40 Smart Highway segment near Wuxi transmitted a fault signal, left rear axle temperature running 14 degrees above normal threshold. The system flagged it, downgraded the vehicle's routing priority, and began modeling the impact on the 7 autonomous logistics vehicles traveling in the same convoy. Wei watched the cascade on his center screen. He did not intervene. The algorithm handled the convoy resequencing in 38 seconds, but at 8:15 a.m., a different situation. A high-speed rail departure from Shanghai Hongqiao was held for 11 minutes due to a platform door sensor fault, a mechanical issue, not a software issue, the kind of thing no algorithm anticipated. The delay rippled forward. At the Nanjing South arrival, 2,200 passengers were now arriving 11 minutes late into a station where 340 autonomous vehicles had already been dispatched to meet them. Wei leaned forward. He pulled up the vehicle allocation screen, cross-referenced it against the real-time demand map for the Nanjing urban zone, and manually adjusted the dispatch priority for a subset of 60 vehicles that had been allocated to a lower priority pickup cluster on the east side of the station. He rerouted them to the main concourse. He then called, on a phone, an actual phone, the Nanjing Highway Operations Desk to flag a likely surge in vehicle density on the Nanjing-Jurong Expressway segment in the next 22 minutes. The system did not make that call. Wei did. Because 19 years of pattern recognition told him the algorithm's model was not weighting the school-run traffic on the Jurong segment correctly for a Tuesday at 8 a.m. in November. The station reporter asked him afterward whether his job felt like it was being automated away. He thought about it for a moment. He said, "The system handles about 90% of what used to require a human decision. But the 10% it cannot handle yet is the 10% that causes the cascades." So the job did not get smaller. It got harder to do badly. That is what the integration layer looks like at ground level. Not a room full of blinking lights running on their own. A room full of people like Wei, whose expertise is now applied to the exceptions rather than the routine, and whose margin for error, because of what the system catches automatically, is effectively zero when something the algorithm did not anticipate walks through the door. What the rest of the world is doing about it here is where the second flip lands. When you look at China's multimodal integration from the outside, the natural assumption is that this is the story about infrastructure spending. China spent more, built more, moved faster. And if you want to catch up, you spend more and build more. That assumption is wrong. And the reason it is wrong is the reason the gap is going to widen rather than close. The European Union launched its Connecting Europe facility, a cross-border transportation integration program with a budget of 33.7 billion euros for the 2021 to 2027 cycle. That is real money. But the program's own midterm review, published in early 2024, identified the primary bottleneck as not funding but data governance. 14 EU member states are operating rail systems on incompatible digital signaling standards. 6 of them are running highway infrastructure management software that cannot communicate with the systems in the countries they border. The money exists. The political agreement on what a shared data protocol should look like does not. In the United States, the bipartisan infrastructure law allocated $66 billion to passenger rail between 2021 and 2026, the largest rail investment in the country's history. Amtrak has used a portion of that funding to begin upgrading the Northeast Corridor, the single most traveled rail route in the country. The corridor runs through 8 states and the District of Columbia. Each of those jurisdictions has its own permitting authority, its own environmental review timeline, and its own elected officials with their own priorities. A signal system upgrade that would take 18 months to complete in a single jurisdiction environment has a projected timeline of 7 to 11 years on the Northeast Corridor because of the sequential approval process across state lines. Japan's linear Chuo Shinkansen, a maglev line under construction between Tokyo and Nagoya, is the fastest train ever built for public use. It will reach 500 kilometers per hour in revenue service. It is also, by Japan's own assessment, a point-to-point speed solution and a system that still requires passengers to navigate the same fragmented last-mile problem on arrival that existed before the line was built. The train is faster. The integration layer is not there. The three specific international actors who have come closest to understanding what China actually built and have begun trying to build equivalent coordination infrastructure are Singapore, South Korea, and Saudi Arabia's Noon project. Singapore's Land Transport Authority launched a unified mobility data platform in 2022 that integrates rail, bus, and ride-hail into a single operational feed. South Korea's Ministry of Land, Infrastructure, and Transport began piloting vehicle-to-infrastructure communication on the Gyeongbu Expressway corridor in 2023. Saudi Arabia's Noom is building the integration layer first, before the physical infrastructure, which is the correct sequence, and the sequence almost no existing city can replicate because they are retrofitting rather than building fresh. What none of them have yet is scale. China's three pilot corridors cover a combined population catchment of 380 million people. The next largest equivalent, Singapore, covers 5.9 million. That is not a criticism of Singapore. It is a measurement of what it takes to stress test a coordination system until it breaks and then fix it. The iteration cycle that produces the version that works at national scale. The scale math payoff lands here. China's integrated multimodal corridors currently serve a passenger catchment roughly equivalent to the combined populations of the United States, Canada, and Mexico. Within those corridors, peak hour throughput, the number of people moved per hour across all modes simultaneously, exceeds the total daily passenger volume of the entire United Kingdom's national rail network every single hour. At peak, that is the dinner table sentence. That is the number that reframes the conversation. And the obstacle that stands between every other country and that number is not money, not technology, and not engineering talent. It is the political architecture required to tell 20 separate agencies with 20 separate budgets and 20 separate sustenance systems that they are now one system and that one of them is going to have to become subordinate to the others. In a democracy, that conversation takes a generation. In some cases, it never finishes. That is not an argument that one system of government is better than another. It is a measurement of what integrated infrastructure actually requires, and an honest accounting of which environments can produce it on a timeline that matters. The question is not whether the West can build this. The question is whether it can build it fast enough to matter. And right now, the honest answer is that nobody knows, because nobody has tried in the way that would be required. Not yet. Where to put your position. So here's the question we're sitting with. China built an integrated transportation system by centralizing data governance across rail, road, and autonomous vehicles under a unified national platform. The results, by the measurements available, are real. The efficiency gains are documented. The scale is without equivalent anywhere else on Earth. But the architecture that made it possible, the ability to mandate data sharing across every operator, every municipality, every vehicle manufacturer, with no opt-out and no veto, is not available to democratic governments by design. That design exists for reasons that have nothing to do with transportation. It exists because concentrated coordination power is also concentrated political power, and history has a long record of what happens when those two things become the same thing. So the comment worth leaving is this. Is the integration model China built something? Democracies should try to replicate through voluntary coordination frameworks and shared standards, accepting that it will be slower and messier and probably less complete? Or is the efficiency gap simply a structural feature of free societies, and the correct response is to invest in the pieces rather than the whole? There is no clean answer. That is why the question is worth asking. Now, if this video changed how you see what transportation infrastructure actually means, there is one more story on screen right now that hits just as hard. While China was building the coordination layer underneath its roads and rails, it was simultaneously doing something just as counterintuitive underneath its rivers and seas, running the data centers that power this entire system from locations that should not be physically possible. Click it, you will not regret it.